The most common example of an object moving in 2 dimensions is a projectile. The only significant force acting on a projectile is gravity, and as such it will follow a curved path through the air as gravity pulls it back towards the Earth. Projectile motion is simply the motion of an object that has been launched into the air at some angle and some velocity. The object in a situation such as this is referred to as the projectile, and its path is referred to as the trajectory. We can describe projectile motion as motion in 2 dimensions, meaning there is both a vertical and horizontal component to the motion. The trick is to describe these 2 motions separately. So let's start with a vertical component. Let's say we have a ball that we drop off of a cliff. This ball starts at rest and will accelerate towards Earth at a rate of 9.8 meters per second squared. If we ignore air resistance, we can assume that the only force acting on this object is gravity. From our free fall equations, we know that the distance that the ball travels can be calculated by taking 1/2 of the acceleration times the time squared. So after 1 second, the ball will have fallen 4.9 meters. 2 seconds later, it will have fallen 19.6 meters, then 44.1 meters after 3 seconds. 4 seconds, the ball will have fallen 78.4 meters, and if it falls for 5 seconds, it will have fallen 122.5 meters. Now let's take that same ball and look at how it moves in the horizontal direction. If we ignore the vertical component, then we can imagine the ball rolling along some frictionless plane in the horizontal direction. So instead of simply dropping the ball off the cliff, we throw it along this track at some velocity, say 10 meters per second. So the initial velocity in the horizontal direction is 10 meters per second. Now once the ball leaves your hand, there is nothing to speed it up or slow it down. It simply moves along at a constant velocity along the plane. After 1 second, the ball will have traveled 10 meters. After 2 seconds, 20 meters. 3 seconds, 30 meters. Each second that the ball rolls, it will move another 10 meters. Now what if the rail is not there? When we take our ball and throw it, not only will we still have a constant velocity in the horizontal direction, but we will also see the ball fall because of gravity. The horizontal and the vertical motion combine together to form a projectile. So after 1 second, the ball will have traveled 10 meters in the x direction and 4.9 meters in the y direction. After 2 seconds, the ball will have traveled 20 meters in the horizontal and 9.6 meters in the vertical. 3 seconds later, the ball will be 30 meters along horizontally and 44.1 meters vertically. This pattern will continue until the ball reaches the ground, and we get that curved motion in both directions that we refer to as projectile motion. We can break down projectile motion into the horizontal motion and the vertical motion mathematically as well. Since these motions act independently of each other, we can analyze them separately. The really nice thing about the kinematic equations is that they can be used to describe motion in the x direction and motion in the y direction as well. So all we really have to do is break the motion down into its x and y components. Now in the x direction, we know that the horizontal velocity remains constant, so acceleration in the horizontal direction is equal to 0. Since we have a constant velocity, any math that we want to do that describes the horizontal motion of our projectile needs to use our constant velocity equation. In the y direction, we know that the ball is accelerating due to gravity at a rate of 9.8 meters per second squared. So any math that we want to use to describe the vertical motion needs to include the acceleration due to gravity. So a projectile is any object that is moving through the air solely under the influence of gravity. The horizontal and the vertical motion of a projectile do not depend on each other. The horizontal motion is constant, the vertical motion is accelerating.